You can't locate a spot to plug your phone in, and it's going to die once more. Is the battery in your laptop on the verge of igniting? How far should you commute in an electric car from your house? It's obvious that we need batteries with greater capacity, longer lifespans, and safety in usage as these circumstances become more frequent. We will thankfully soon have access to new battery technology. Welcome back to Voltage Future. In today's video, we'll check out some of the incredible new batteries that revolutionize everything. Isn't that amazing to hear? We need to know more about them and check out their super special qualities that make them stand out from everything. With no further delay, let's get into the video. Number 5. The NANOBOLT lithium-tungsten batteries. It produces rechargeable lithium-tungsten batteries which advance the science of lithium batteries. Due to the increase in ion storage area brought on by the addition of tungsten and carbon multi-layered nanotubes to the anode materials, recharge rates and total energy storage are improved. The energy tech market is where the NANOBOLT lithium-tungsten battery mostly works. The wide market sectors for tech, enterprise and tech hardware are likewise served by NANOBOLT lithium-tungsten battery. Researchers at N1 Technologies Incorporated introduced multi-layered tungsten and carbon nanotubes to battery anode materials which link to the copper anode substrate and develop a nanostructure resembling a web. More ions can connect to this large surface during recharge and discharging cycles. Because of this, the NANOBOLT lithium-tungsten battery can be charged more quickly and can hold more energy. The NANOBOLT lithium-tungsten batteries market report describes the market area in detail, which is further divided into sub-regions and nations/regions. Along with the data on the market share in each country and sub-region, this section of the study also contains information on potential profits. This research contains the market share and growth rate of every region, country, and sub-region throughout the expected time. The NANOBOLT lithium-tungsten batteries market research report also contains essential research data and proofs that make it a valuable resource record for managers, analysts, industry professionals, and other key individuals to have a ready-to-access and self-analyze study to grasp market patterns. Number 4. Fluoride-ion batteries. Lithium-ion batteries and fluoride-ion batteries both operate mostly on the same concept. During the charge and discharge cycles, negatively charged fluoride ions rather than lithium ions shuttle between both the cathode and anode. The first major benefit of this prototype is that the electrolyte is solid and inert, meaning that this type of battery is less likely to catch fire. Research teams from Kyoto University and Toyota Motor have created a model of this kind of battery that can overcome the drawbacks of lithium-ion batteries mentioned previously. This battery's energy-dense copper cathode and lanthanum fluoride anode can both be damaged in the event of a malfunction. These materials have substantially better reversibility and fluoride ion capacities than lithium-ion batteries do. According to experts, this method would allow mass-produced, inexpensive electric vehicles to go up to 1,000 kilometers or 620 miles on a single charge and have lightweight batteries. The battery may be able to provide around 3 times more energy density, which would make the concept of electric airplanes a reality. On the other hand, solid-state fluoride-ion batteries are also more than 3 times less expensive than lithium-ion batteries, carrying a $30 price tag per kilowatt-hour. One drawback of this prototype may be the rapid deterioration of the electrode materials utilized, which shortens battery life. However, researchers believe that they have found a solution to this issue by employing cobalt-nickel-copper alloy. Another difficulty is the battery's solid electrolyte's high temperature requirement. Nonetheless, in certain experiments, the battery was successfully operated even at ambient temperature. However, many experts estimate that it will be at least 8 years before commercially viable fluoride-ion batteries are available, which is a fairly typical timeframe for moving a novel battery solution from the lab to production. Meanwhile, researchers around the world are competing to develop better batteries during this time. Number 3. Structural batteries. Structural batteries are materials or constructions with many uses that may work as a battery or any other electrochemical energy storage device while maintaining structural integrity. Researchers of the Chalmers University of Technology are creating the lighter, more lightweight version of the Model Y while also working on a remarkable massless structural battery project that aims to transform a vehicle's body shell into a battery. The team, which has already developed a number of structural battery prototypes, wants to advance the technology by depositing the active electrode materials on carbon fiber rather than the aluminium foil that is currently used. The anode will also be made of carbon fiber, and the separator will also be made of extremely thin fiberglass fabric. Since carbon fiber is as strong as aluminium but much lighter, it can be used to design structural batteries that are rigid and have greater energy storage capacity than the best prototypes currently available. However, they still have a few times less energy density than the current oxide-based lithium-ion batteries. By using the vehicle's chassis as a battery, this technology will be significantly reducing the weight of the vehicle. This advancement allows for thin and even flexible structural batteries, and the potential uses of these new multifunctional systems are only limited by our imagination. The next generation structural battery in particular has a lot of promise. With that, we've come to the middle of this video. It's exciting to get to know in detail about these batteries that are revolutionizing the world. If you need to know more about these batteries, continue watching the whole video. Before we get into the rest of the video, subscribe to our channel and bang the bell icon for more notifications whenever we upload a new video. Number 2. The sodium-ion battery. In the meantime, the largest lithium-ion battery manufacturer in the world, CATL, has announced the manufacturing of a sodium-ion battery in 2023. The basic mechanism of the sodium-ion battery is similar to that of the lithium-ion battery, but here the charge is stored by sodium ions, which are much more copious on Earth and are widely distributed throughout the world in contrast to lithium. In addition, because sodium and lithium have different properties, the cathode materials of the sodium-ion battery are different. But even though graphite has virtually reached its theoretical limit, it may still be improved by adding silicon or silicon oxide for hard carbon. Due to the differing storing techniques, the theoretical capacity can be larger than for graphite in lithium-ion batteries, depending on a variety of additional conditions. The sodium-ion battery has the advantage of fast charging performance, allowing it to regain 80% of its charge in 15 minutes at room temperature. In addition, it offers a capacity retention rate of more than 90% in a low temperature environment of -20°C, challenging many modern lithium-ion batteries in these regards. However, it has a significant drawback of low energy density as compared to other batteries. Currently, the first generation of sodium-ion batteries can achieve a capacity of 160 watt-hours per kilogram, comparable to lithium-ion phosphate batteries, which are, for example, found in Tesla Model 3s with standard ranges. Still, they are more cost-effective because sodium-ion batteries are widely available. For instance, the recently found vanadium pyrophosphate is a potential material because of its great thermal stability, which not only addresses safety concerns but also eliminates the need for a complex thermal control system that often consumes more space and reduces EV range. The last component of fireproof batteries, aside from vanadium pyrophosphate, which may be used as both a cathode and anode material to increase safety and give long battery life while maintaining the same high voltage. Scientists are now focused on sodium-ion batteries, but since lithium-ion batteries have previously been used in portable electronics and electric cars, we shouldn't dismiss them too fast. And finally, at number 1, the 100-year battery. Enriching a lithium-ion battery with nickel and silicon, as well as adding silicon to the graphite anode, are two ways to increase energy density. This is a challenge because these chemistry innovations are prone to rapid degradation and have even more serious safety issues, but these were the gradual advancements that made it possible to produce 600-mile EVs in 2022. It has already been demonstrated that an NMC532 cell with a lead oxide composition of 50 nickel, 30 manganese, and 20 cobalt can maintain more than 90% of its initial capacity up to 1 million miles of operation in 2019. The media dubbed this battery the 1 million mile battery. Dalhousie University, a research partner of Tesla, is concentrating its efforts on mid-range batteries based on unfashionable NMC532 cells constructed with only sufficient graphite without silicon. It took another 3 years of research after the million-mile battery, which can be thought of as a 20-year battery, to produce the 100-year battery. So, could you imagine that a battery could last longer than a typical human life? First of all, this technology is essential to Tesla's long-term strategic vision. Its autopilot will eventually pave the way for autonomous driving, and this battery can power the company's network of robocabs. In addition, a vehicle with such a long life cycle is much more advantageous to the grid economically. The capacity of electric cars to store energy will ultimately provide a solution to the primary issue with renewable energy, while also enabling EV owners to sell excess energy to businesses in order to balance differences in energy output and consumption. And with that, we come to a close. What are your thoughts on these batteries? Are they really revolutionizing everything in the world? Share your thoughts on the space given below. If you enjoyed this video, then like, share, and subscribe to Voltage Future for more such content. Goodbye.